Hey guys, here is one of the problems from the game we played. The question was to find the area inside both of these curves. I forget what number it was. It was maybe the fourth or fifth question down. But this is straight out of the Paramedics and Polar Bear activity that we did. So first of all, obviously we need to get a good picture. So let's get that in there real quick. 2 sine theta plus cosine theta. And this is, let's just see if this is good enough. I'll adjust it if we need to. Alright, there's 2 sine theta. Here comes sine plus cosine. Okay, that's not bad. So let me just draw it so we can play around with the regions and stuff. So alright, I got one of them. One of them is basically like this. And the other one, almost looks like a Venn diagram or something like that. I don't know why that's funny, but whatever. Let's see. Let's go up in here, and maybe there. How's that? Okay. All right. So the question is inside both. So inside both is essentially all this, right? And I think in class, especially under the time pressure of playing a game, you want to just get it done. I'm sure you basically just did something like, integral 0 to whatever, and then 1 minus the other, or something like that. But this one's a little different because they're both inside. If I were to draw this radius to where they meet, this radius is doing all the work, right? If I start here and sweep up to this point, well then the curve I'm using is this one. Okay, so again, if I start here and if I draw radii all through here, just keep drawing them. Every time we go up a little bit of theta, I'm bound by this curve. Okay, up a little bit of theta till I get to here. And I think, what did we figure out? Was that the one that was pi over 4? Let's see, 2 sine theta equals sine theta plus cosine theta. So that's sine theta equals cosine theta. So right. So when does sine equal cosine? Or when does tan theta equal 1? Right? If we divide both sides by cosine, as long as cosine isn't 0. So sine theta equals cosine theta. Theta is pi over 4. And what was that? 5 pi over 4, I guess. That's where that would equal each other. So the first time that happened would be here. Okay, so pi over 4. So from 0 to pi over 4, this curve, which I believe is, I'll call that R1, is what I need. So my first part of my integral is going to be from 0, the area is going to be 0 to pi over 4, 1/2 2 sine theta squared. And that pretty much covers this region right here. But as soon as I get there, as soon as my radius hits this point, it changes. Now my radius, if I were to keep drawing radii over and over again, now it's being bound by this curve. That's the curve I want to find the area for. And it keeps going, keeps going, keeps going. Obviously, if I draw infinite number of them, it's going to shade in the whole region. So I need to go from pi over 4 to when sine theta, this is R2, right? When sine theta plus cosine theta comes to 0. Okay? So sine theta plus cosine theta needs to get to 0. Well, sine theta plus cosine theta equals 0 when sine theta equals negative cosine theta, and that's got to be when theta is 3 pi over 4. Okay, so my next boundaries are going to be from pi over 4, which is here, all the way right to here, 3 pi over 4. Okay, and that's going to be for R2. So 1/2 sine theta plus cosine theta squared d theta. And that's what made this one tricky, is it ended up being a two-parter. Okay, hopefully that helps. Obviously you can put that in the calculator and get whatever it said on the answer key. I'll save a little bit of time here so I can try to answer more questions. But this was the structure of it. Okay, let me know if you have any other questions, and I will talk to you guys later. See ya.